Alright, welcome to a lesson on finding arc measures in circles. And guess what? Again, very definition and theorem heavy. So, definitions. The central angle in a circle, an angle in a circle whose vertex is the center of the circle. The circular arc is the arc created on the edge of the circle by the central angle. The measure of the arc is the central angle measure. So our central angle and its corresponding arc have the same measurement in degrees. So you recall a circle's 360 degrees, so a central angle and its arc take up the same amount of that 360. So some special types of arcs. A minor arc is a circular arc whose measure is less than 180 degrees. A major arc is a circular arc whose measure is greater than 180 degrees. And a semicircle is a circular arc whose measure is 180 degrees. And I just realized I didn't spell circular right. So, circular. There we go. So a minor arc is a small arc, a major arc is a big arc. Semicircle is in between. And we have a picture here. So the central angle is in red. The circular arc is in green. It's also a minor arc. And the major arc associated with this circle is in blue. Now, the measure of the central angle is 80 degrees, which means the measure of its corresponding arc is also 80 degrees. And down here, this is what's called arc AC. So this little arc means arc. And then we have the measure of arc AC equals 80 degrees. So again, central angle and its arc, same measure. They're equal. It's very important. Arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So we have circle D here, and we have arc ABC, and the measure of arc ABC equals the measure of arc AB plus the measure of arc BC. What this basically says is that we're going to take this piece here, add it to this piece, and we get the whole thing. So it's kind of a self-exclamatory thing. It's a bit silly. When you think about it, to actually say it, if I have two things that are put together, if I want to find out how big the whole thing is, I add those two pieces up. Alright, so let's do an example with that. So we want to find the measure of arc WXY. So we want to find the measure of arc WXY. Arc WXY. WXY is right here. So we need to find the measure of the arcs. And again, the measure of an arc is the measure of its central angle. So WX is with WZX. That's 100. So this is 100 degrees, which means that this is 40 degrees. So I add them together and I find that it's 140 degrees. So that's our answer. Please note also, I know this picture is not to scale, so don't assume it is to scale unless it says so. So I just threw some numbers in here. Congruent circles theorem. Two circles are congruent if they have congruent radii. So here circle A is congruent to circle B because their radius or their radii are congruent. So they're both 2, they're both 3, they're both 4. So if any circle were to have radii that are equal and then therefore congruent, those circles would be congruent circles. They would be the same circle. Congruent central angles theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So, arc BC is congruent to arc AD if and only if, that's what that IFF means, angle AXD is congruent to BXC. And we know that they are if we look, because we have that vertical angles. So, as long as within the same circle, or if you know the circles are congruent, if you have a central angle that's 50 degrees and another central angle that's 50 degrees, those angles are congruent, and those arcs are also congruent. So that's what this theorem tells us. Similar circles theorem, all circles are similar. If we think about this, we only have one real dimension to go off with a circle, and that's the radius. And if you're comparing two circles, you're always going to get the same fraction no matter what. So just remember that all circles are similar.